Okay, let's start talking about it. They give us a situation here. They're having people do sit-ups. We've got 9 individuals. The average number of sit-ups was 26.2. The standard deviation was 6. And so that's the information we have in our problem. Part A asks us to calculate the standard error, right? That's nothing but S over the square root of n. And that works out to 2. What does that mean?
Standard error of our sample is 2.
Okay, but what does standard error of the sample tell us?
The differences in the values from the mean.
Okay. That's actually the way the book states it. It says roughly this is the average distance between the sample and population means over all random samples of n equals 9 that can be selected from this population. Okay? I really don't care if you got that answer memorized or not. That's not really what I'm looking for out of this. That's technically what it is. In reality, what does it measure for us?
Sit-ups, right?
We're measuring sit-ups, but what about sit-ups does that tell us?
I don't know. It's within like I really don't know. I left it kind of blank, but I thought it was like maybe 2 for each, like the 26.2.
Okay. We know that X bar is distributed as a mean and standard deviation, a normal distribution.
Is it 2 sit-ups or 2 for every standard deviation away from it?
Yes, that's essentially what it is. Or the width of our bell curve is 6 of these standard errors wide. So that tells us that if we draw a bell curve for the sit-ups, for the averages of sit-ups for samples of size 9, these X bars should be centered at 26.2, and then we're going to do plus 2, plus 2, plus 2, so we're going to do 3 of those on one side, 3 on the other side, and that comes up with the width of our distribution. So anything that talks about this is our sample estimate of the width of the distribution, or the spread of the distribution of X bars, that's what we're looking at. And if you happen to come up with the way the book says it as the average distance of individual X bars from the sample mean, that's fine too. Is there a question there?
Yeah, I'm still not understanding exactly what that shows you on like a bell curve or whatever. I mean, I know that would be like standard deviation, just standard error, but so each
This
of
would
those
be-
intervals is 2. Is that
Yep.
all that it's telling us? Okay.
So each standard deviation is 2.
Yep. This is exactly 2y. That's all it says.
And what does that help us calculate? I mean, I know that helps us with confidence intervals or whatever, empirical rule, but I don't understand exactly what that's saying. I mean,
Well, exactly what it's saying is what the text says, or what Dan said. It's the average distance an individual value is from the mean. However, what it does for us is it tells us that we should expect the values of this to fall within 26.2 plus or minus 2, approximately 68% of the time.
okay.
And within plus or minus 26.2 plus or minus 4, approximately 95% of the time.
Okay.
And so that empirical rule, it tells us basically how they're going to be distributed.
So could you just say standard error equals the width of the standard deviation?
I would accept that because I know what you meant, but it's the width of the bell curve. Standard error is our best guess at the width of the bell curve for X bars. Okay? Part B, all they wanted is a calculation of the confidence interval. That's pretty easy. 26.2 plus or minus, what was T star? 2 point what? 2.36? Yeah, I
Yeah,
think I had 2.31. In the text, and this is 2, right? No, times 2. They did a no-no in the solution set. When I put this up on Blackboard, remember that in this case, the solution here says 26.2 plus or minus 2 times 2. So they didn't actually get the actual T star. They used the approximate 2 value. And if we were up at a sample size of 50 or 60, I'd accept that. But a sample size of 9, I really want to see that T-star down here because there's a big difference between 2 and 2.3. Okay. Part C, what is the interpretation of this interval that we've got here?
We are 95% certain that this population mean is less or between 21.5 and 122.
Okay. There's another way to state that. That's the way the text often states it, and I'm perfectly satisfied with that description of it. Another way to state it is that 95% of similar intervals would cover the population mean, so this is one of those intervals calculated such that 95% of them would hit cover it. But I think it's easier to think of it in terms of the way you described it. Questions? Yes, there is. It's on Blackboard. Yep.